steam, you actually load steam into the CASA and then run it. So on the left, you can see the microscope field of view. These are just the cells that the CASA will count. And then once you run it, you'll get a count summary with the total amount of cells, modal, and then progressive modal, and the percentages associated with that. Within that, we have velocity distributions of how fast these cells are moving. So rapid moving cells, medium moving cells, and slow moving cells. And then cells that are exhibiting no motility, or they're static. So these are the semen parameters and ranges set by CASA. So the total cells, again, is just the total number of sperm cells at the microscope where CASA is counting within that microscope's field of view. The percentage of modal cells and progressive modal cells have to reach certain path velocities, as well as progressive velocity for modal cells, and straightness for progressively modal cells, as they need to be moving linear. And then within our velocity distributions, they all, for rapid, medium, and slow, they all need to meet certain path velocity threshold levels to be categorized as such. And then again, static cells are cells exhibiting no motility. They're immobile. For our statistical analysis, all our data was analyzed as a fixed effects model using proximate limits in SAS version 9.4. Our alpha was set to 5%, and significance was determined when our p-value was equal to or less than 0.05. So here's the table with our pre and post treatment averages for both our control and cottonseed meal group. We observed a significant difference in our cottonseed meal group when compared to our control group at 297.53. Over time, we observed our first significant difference in our cottonseed meal fed group at week 5, and then reported lower averages for the remainder of the study. Our two pre-treatment groups are represented by the white and yellow dashed lines, and then our control group post-treatment allocation is represented by the green line again, and then our cottonseed meal fed group is the red. For total motility, we observed another significant difference between our cottonseed meal fed group and our control group. We saw a significant or a dramatic decrease in our cottonseed meal fed group from 79.6% pre-treatment allocation to just above 60% of total motility. We observed our first significant difference in our cottonseed meal fed group at collection sample number 2, and reported lower averages for the remainder of the study. It's interesting to note that both our pre-treatment allocation groups as well as our control group seem to be following similar trends, while our cottonseed meal fed group is just steadily decreasing. For cells exhibiting progressive motility, our cottonseed meal fed group had another significant difference when compared back to the control group. And it's interesting to note because our treatment group actually had a higher percentage pre-treatment allocation, but then at the conclusion of the study, they had dramatically decreased to just over 40% of progressive modal cells. So we observed our first significant difference in progressive motility at collection sample number 5, and reported lower averages for the remainder of the study, while our other 3 groups seem to be still following the same trends. For cells exhibiting rapid motility, again, just like progressive motility, our cottonseed meal group was actually higher pre-treatment, and then at the conclusion of post-treatment allocation, we had a significant difference when compared back to our control. We observed our first significant difference in our cottonseed meal fed group at collection sample number 3, and again reported lower averages for the remainder of the study. There's a little more variability in these velocity or cell velocity parameters, but it seems that our other 3 groups seem to be following a more similar trend in our cottonseed meal fed group. For medium motility, we did observe a significant difference between the cottonseed meal fed group versus our control group. It wasn't as pronounced as our other parameters, but it was significant. And here we saw our first significant difference a little bit later than our other parameters. We observed this one at collection sample number 8, but after that we did report lower averages for the remainder of the study. slow motility, this is our only semen parameter that we analyzed that was not significant. However, we did see a rise in the average of, or the percentage of cells exhibiting slow motility in our cottonseed milk-fed group when compared to our control group. It seems to be that all of our groups are following similar trends until later on in the study, until about collection 15, and then we did report higher averages for our cottonseed milk-fed group again, but this was not statistically significant at post-treatment application. The amount of static cells, we saw a dramatic increase in the amount of static cells in our cottonseed milk-fed group when compared back to our control group. We increased from 10.21% static cells to over 25% of the static cells within the ejaculate. Our first significant difference was observed on collection sample number 4, and then we reported higher averages for the remainder of the study. By collection sample 20, our cottonseed milk-fed group was reporting 34% static cells within the ejaculate. And then again, while our other 2 pre-treatment groups, as well as our control group, seem to be following similar trends throughout the study. So we observed a significant difference in our total cells observed, total motility, progressive motility between our control and cottonseed milk-fed group. Decreased total motility percentages have been shown to negatively affect the number of piglets born, and decreased progressive motility has been shown to reduce the farrowing rate. In our velocity distributions, we saw a significant difference in our cells exhibiting rapid motility and medium motility. We did not observe, again, a significant difference in our slow-moving cells. However, we attribute the majority of that to the rapid and dramatic increase in static cells that we observed. And an increased percentage of slow-moving cells or static cells has been correlated with the failure of sperm cells reaching the oviduct to achieve fertilization. So currently there are no registered toxins available for use for feral swine control within the United States. The primary challenge is the development of a species-specific oral delivery system to deliver toxins or other pharmaceuticals to feral swine, while also minimizing instances of non-target mortalities or consequence. Our results indicate that inclusion of 60% cottonseed milk of the total diet containing a total gosfol level of 0.74% had a significant negative effect on the fertilizing potential of these treated boars. Cottonseed milk containing high levels of total gosfol or the development of a supplement infused with gosfol may help to mitigate the rapid expansion of feral swine in the United States, while also minimizing the potential of non-target mortalities that other highly toxic baits such as warfarin and compound 1080 cannot offer. So some ideas for future studies, the effects of gosfol on hyperactivation of boar spermatozoa. And so we know for sperm to achieve hypermotility or hyperactivation motility, there's an increased need for ATP synthesis within the midpiece. And so as we know from this slideshow, this presentation, there's gosfol has a degenerative effect on the mitochondria. So this would lead us to believe that there'd be lower percentages of actual sperm that become hyperactivated within the oviduct of the female. Effects of cottonseed milk with higher proportions of the negative gosfol enaminer on boar spermatozoa. And so in our study, the cottonseed milk that we utilized had higher proportions of the positive enaminer. And we know that the negative enaminer is more toxic. So where we see a more pronounced effect in spermatogenesis on the motility of the sperm produced by these treated boars. And then also the palatability of gosfol infused baits for feral swine consumption. So one of the main challenges with battling or combating feral swine is they're opportunistic omnivores, and so they would eat anything. So how do we get them to stay in one area and ingest enough gosfol or enough cottonseed milk to take effect and actually affect the total population? So I'd like to thank Charles State University for allowing me to conduct this research. The Texas Department of Agriculture for the funding for this research. My parents, Catherine and Mac Baker, professors, especially Dr. Gay and Dr. Roper, Dr. Smith, being on my committee, helped me through this process. as well as the Tarleton State University Farm for allowing me to do my research out there, as well as my employment for the last 6 years. My fellow graduate students for helping me out through this process. It's been a ride. And then all the friends I made throughout my undergraduate and graduate career here at Tarleton State University. I'll now open the floor for questions.